In order to make the graphs for the acceleration lab, your data needs to look something like this. If you had extra trials off to the side, move them a little bit more off to the side so you can follow along. As a quick reminder, with your numerical values, you need to make sure that there are only numbers in those cells. You cannot do this with the units in the cells. Your units must be with the titles. So the first thing to make our graphing easier is we want to copy our displacement column and we want to paste it right next to our average column. From here, we want to select both columns and we want to insert a scatter plot. We want to do the most basic scatter and it'll come up with a graph like this. Now we need to be able to work with a larger version of this graph, so what we are going to do is say move chart and move it to its own page. From here, we also want to change the formatting so that we have an equation and a line. So we're going to move this up to the side. Go ahead and delete the legend. And what you'll notice here is that our line doesn't really match our data. And so we actually want to format the trend line, and rather than doing a linear regression, we want to do a polynomial with an order of 2. And we want to set our intercept to 0. The way to think about this is at 0 displacement, the cart should take 0 seconds to go that distance, which makes sense. And every other option looks good. You'll notice that we have a curve now, and hopefully your data looks a little bit better than this. We want to go ahead and edit our titles. So in this case, we should have time in seconds. And then we also should be editing this to displacement. And this should be in meters. What we want to be able to do now is we want to be able to measure our slope values, but we can't do that until we have our grid lines. So you right click on your X values and you want to add major grid lines and you want to add minor grid lines. The Y already has the major and minor, so that should be good now. At this point, you want to right click on the graph and you want to say copy. It'll probably be easiest to put this into a one-page notebook, and so you can say paste and you will get the graph here. What we want to be able to do now is we want to be able to draw tangent lines, and your laptops are really good for this. So in this case, we want to draw lines, and these are going to be tangent lines for the graph. And so I am going to do something like this. And what you can see here is, in this case, my tangent line is intersecting or touching the curve at roughly a little over 0.8 seconds. And so you can actually measure and figure out exactly the time. So that'll be the time that you use. And now we can measure the actual slope of that tangent line. So in this case, we can see that at 0.4, it's going to be at this intersection. And then we can look for another easy intersection to work with, probably about the 1.4 seconds. And we can do the rise over the run. And so if I were to do that, just to show you as an example, so we could, from here, we can measure the rise. And if we go from here, that'll be our run. And this is just crudely hand-drawn, but you can get the main idea from here. So you want to measure the tangent line to get that value. You want to do a total of 10 different tangent lines at 10 different points that are evenly spaced around the graph. You can do this on multiple graphs, so you can paste the graph again multiple times so you don't clutter it up too much. Those slope values, if you think back to when we first started talking about our DT graphs, the slope values of a DT graph tells you the instantaneous velocity. And so when we go back to our Excel spreadsheet, we can create a time versus velocity, and whatever time it intersected or touched the curve at, that would be like the 0.8 seconds there. And the slope value, we'll just go and say it was a 2.87 value, and in this case our velocity is going to be measured in meters per second. And then once you have your 10 data points, then you can be able to graph that going back to the scatter plot, and ideally that will be a straight line. It'll most likely be a diagonal line, and you want to find the formula with the linear regression. That slope value of your VT graph will be your acceleration. The next graph that you want to do is what we call a DT squared graph. And to do that, we're going to manipulate our data a little bit. So we're going to copy this, and then at a different location, we want to paste just the values. And you want to check to make sure that that is correct. Now, we want to shift the displacement over, and we want to create a column in between called average squared. And this will be in seconds squared for the units. And the way this is going to work is you can just say, we're going to set up a formula that is equal to this value times itself. Or we can also do a squared function. And from here, we can click on this lower right corner and we can drag the formula and it will automatically copy. We can always check to make sure that it's doing this correctly over there. And now what we want to do is we want to select both of these columns and we want to create a scatter plot. And we want to again move this to its own page. And we want to add the trend line. So we go back over here and we add this. Move this up to the corner so we can see it better. And then delete the legend. And this is going to be the slope of your dt squared. So this will be a dt squared graph. And down here should be time squared in seconds squared. And this should be displacement. Always check your values to make sure though. And what you want to do is you want to compare the slope of your dt squared graph to the slope of your vt graph. We'll go through this more in class, and that will be how you will calculate your percent error.